Hello, we're going to finish up section 10.4 today, and focusing on classifying conic sections. Our goals for today are that if we're given the equation of a conic in general form, we'll be able to recognize whether it's a parabola, circle, ellipse, or hyperbola. And secondly, that we can write this equation of a circle in standard form. In addition, we'll spend a little bit of time reviewing the work from our last three sections to hopefully clarify any points that you may have missed. If it would help you to have the equations for all four conic sections in one place, you might hit pause and write all of these down at this point. The only one that you haven't seen in the previous 3 weeks is the equation of the circle. The x minus h quantity squared plus the quantity y minus k squared is equal to r squared, where h comma k would represent the center and r would represent the radius. You did see this back in your geometry days. Because a circle is going to be the same horizontally and vertically, there's really only one equation for circles. Just want to remind you of the key features of the equations when they're in standard form. So if you have an equation in standard form, you would know which type of conic section it was. So for the parabola, again, here's your equations. In standard form, you're going to know it's a parabola because there's only one squared term. X and y will be on different sides of the equal sign, and one set of the parentheses is going to have a coefficient, that value of 4p, in front of it. For an ellipse, you're going to know it's an ellipse if it's in standard form because there's two square terms that are being added. The equation is going to have fractions in it, and one side of the equation will equal 1. For a hyperbola, here's your equations. We're going to know it's a hyperbola if the equation is in standard form because the two square terms are being subtracted. It will also have the fractions and be equal to 1. For a circle, you'll know that it's a circle because there's no fractions. You have the equations equal to r squared. You could also say because the two terms are being added together, two square terms being added together and equal to r squared. Now, it is possible that it could equal 1 if the radius is 1, but in any other case, it would equal a number other than 1. The next 4 slides, we're going to be looking at some examples, and in those examples, we're going to identify the type of conic section. We're going to rewrite the equation in standard form. We're going to sketch the graph of the conic section, and we're going to identify all of the key features for that conic section. Example 1, we have 4x squared plus 4y squared minus 32x plus 24y plus 64 is equal to 0. We know this is a circle because there are two square terms being added with the same coefficient in front of each square term. Next, we're going to get this into standard form. So if we group our x terms and we group our y terms each in their own set of parentheses, then we're going to factor out the coefficients in front of those square terms. So factoring out a 4 from each of the x terms, factor out the 4 from each of the y terms. So we get 4 times the quantity x squared minus 8x plus 4 times the quantity y squared plus 6y plus 64 is equal to 0. Now we're going to complete the square. Half of negative 8 is negative 4. Negative 4 squared is positive 16. But we didn't just add 16, we added 4 times 16, we've added 64. So to balance it out, we subtract 64 outside of our sets of parentheses. To complete the square for our y terms, half of 6 is 3. 3 squared is 9, so we're adding that inside the parentheses, but we didn't just add 9, we added 4 times 9, 36. So to balance it out, we're going to subtract 36 outside of the parentheses. Now if we do a little bit of simplifying, half of negative 8 is negative 4, so we have 4 times x minus 4 quantity squared. Half of our b value 6 is 3, so 4 times the quantity y plus 3 squared. If we combine all of these constants, 64 minus 36 gives us negative or minus 36 is equal to 0. To continue, we're going to want to add 36 to both sides. So now we have these is equal to positive 36. And if you recall, the equation for a circle does not have coefficients out in front, so we're going to have to divide everything by 4 on both sides of our equation. On this side, the 4s are going to cancel out. On this side, 36 divided by 4 gives us 9. So we end up with the quantity x minus 4 squared plus the quantity y plus 3 squared is equal to 9. Here's the equation of our circle in standard form. So looking at that, we know our center is at positive 4, negative 3. Our radius r squared is equal to 9, so that means r is equal to 3. And using that information, we can make a graph. The first thing you would put on your graph is your center, the point 4 comma negative 3. Since our radius is 3, okay, you can go 3 in whatever direction you want. I tend to go up, down, left, and right. So if I go 3 spaces up, put a point, 3 spaces down, put a point, 3 spaces to the left of the center, put a point, 3 spaces to the right of the center, put a point, and then using those 4 points, you can sketch in your circle. Now, if you want to have a little fun and do some additional points, kind of estimating how far 3 would be away when you're not going directly up, down, left, or right, you certainly can. Next up, example 2, 9x squared minus y squared plus 36x plus 2y plus 26 is equal to 0. What type of conic section is this? You might find it helpful to hit pause for a moment right now and think about it for yourself. You should recognize that this is a hyperbola because we have a minus sign in front of our square, one of our square terms. We also know it's horizontal because our x squared term is the positive term in this case. Now we'll get it into standard form. If we group our x terms in one set of parentheses, group our y terms in front of the other set of parentheses, make sure you keep that minus sign with the y squared. Now if we factor out the coefficients in front of those square terms out of everything inside the parentheses, so we're going to factor out the 9 from both of the x terms. We're going to factor out a minus sign from both of the y terms, which is going to give us y squared minus 2y plus 26. And now we're going to complete the square. Half of 4 is 2, 2 squared is 4, so that's what we're adding inside of our x parentheses. But we didn't just add 4, we added 9 times 4, we've added 36. So to balance that out, we're subtracting 36 outside of the parentheses. Half of negative 2 is negative 1. Negative 1 squared is positive 1, so we add that inside of our y parentheses. But we didn't just add 1, we added a minus 1. So to balance out a minus 1, we're going to add 1 outside of the parentheses. If we simplify this, half of 4 is 2, so we get x plus 2 squared. Half of negative 2 is negative 1, so we get y minus 1 squared. 26 minus 36 plus 1 gives us a minus 9. If we add 9 to both sides, then you have this is equal to positive 9. Our last step, since we want to get one side to equal 1, is going to be to divide everything by 9. 9 goes into 9 one time. 1 goes into 9 9 times, and 9 divided by 9 is 1. So our equation in standard form is the quantity x plus 2 squared over 1 minus the quantity y minus 1 squared over 9 is equal to 1. Identifying our key features, our center is the point negative 2, 1. Our a value, now remember in a hyperbola, a is always with the positive term. It's not necessarily the biggest number. So a is 1. So our vertices, because it's horizontal, it's going to be one space to the left and right of our center. So our vertices are at negative 3 comma 1 and negative 1 comma 1. Since b squared is 9, b would equal 3, which means our co-vertices are 3 spaces above and below our center. So that takes us to negative 2 comma 4 and negative 2 comma negative 2. To find c, you have to use the equation for the hyperbola relationship. So a squared plus b squared is equal to c squared. We know a squared is 1. We know b squared is 9 equals c squared. So c squared equals 10, and c would equal the square root of 10. So our foci are square root 10 spaces to the left and right of our center. So negative 2 plus and minus square root 10 comma 1. Equation for the asymptotes in a horizontal hyperbola, y equals negative k plus and minus b over a times the quantity x minus h. So if we substitute in our values for h, k, a, and b, we get negative 1 plus and minus 3 over 1 times x plus 2. And you can even simplify, since 3 over 1 is just 3, y equals negative 1 plus and minus 3 times the quantity x plus 2. For our graph, we'd start with our center at negative 2, 1. Then we'd put on our vertices at negative 3, 1, and negative 1, 1. Put our co-vertices, negative 2, 4, negative 2, negative 2. Draw in that guiding rectangle. Then we'd want to draw in our asymptote, so through the diagonals of the rectangle. And then finally, you would put on the branches of the hyperbola. So start next to an asymptote, through a vertex, and next to the other asymptote. Start next to an asymptote, through the vertex, and next to the other asymptote, and you have your graph for your hyperbola. Next up, example 3, 2y squared plus x minus 24y plus 73 is equal to 0. Feel free to hit pause and take a moment to think for yourself as to which type of conic section you think this should be. This is a parabola because there's only one squared term, that 2y squared. We also know that it's horizontal because it's the y being squared and not x being squared. If we get this into standard form, group your y terms into one set of parentheses, everything else can be on the outside of that. Factor out the coefficient from in front of the y squared. So in this case, if we factor out 2 from everything inside the sets of parentheses, we get 2 times the quantity y squared minus 12y, and then plus x plus 73 equals 0. If we complete the square, half of negative 12 is negative 6. Negative 6 squared is 36. But we didn't just add 36, we've added 2 times 36. So we've added 72. To balance that out, we're going to subtract 72 out here. If we simplify this, half of negative 6, or half of negative 12 is negative 6, so we end up with y minus 6 quantity squared times 2 plus x plus 1 from the 73 minus 72. Now, parabola in standard form is going to have the square term all by itself on one side and everything else on the other side. So let's subtract the x and subtract the 1 to give us 2 times the quantity y minus 6 squared equals negative x minus 1. I'm going to go ahead and factor out anything that's in front of the x on this side. So if I factor out the negative, now you have the 2 times the quantity y minus 6 squared is equal to negative the quantity x plus 1. And our last step to get this into standard form is to get this square term all the way by itself. So if we divide everything by 2, now dividing by 2 is the same as multiplying by 1/2. So we end up with the quantity y minus 6 squared is equal to negative 1/2 times the quantity x plus 1. Our vertex is going to be at negative 1, 6. Make sure you bring the x coordinate first. Because this is a horizontal parabola, your axis of symmetry is going to be a horizontal line, and it's going to start with y equals, and it'll equal the y coordinate of your vertex, so y equals 6. To find our focus and directrix, we have to find p. We know that 4p is equal to negative 1/2. So if we divide both sides by 4, p is equal to negative 1/8. So p, the distance from the vertex to the focus, is negative 1/8. So our focus is 1/8 of a space to the left of our vertex. So 1/8 of a space to the left of negative 1 is going to put us at negative 9/8, 6. 1/8 of a space to the right of our vertex is going to give us a vertical line for our directrix at x equals negative 7/8. And for our graph, if we put our vertex at negative 1, 6, we have our axis of symmetry here at y equals 6, our directrix here at x equals negative 7/8, and we know our parabola opens to the left because our focus is on the inside of that. Sketch in your curve. Our last example for today, example 4. 4x squared plus 9y squared minus 40x plus 36y plus 100 is equal to 0. Again, feel free to hit pause for a moment and decide which type of conic section you think this is. We know this is an ellipse because we have 2 squared terms that are being added together, and they have different coefficients in front of them. If they have the same coefficients, if these were both 4s or both 9s, that would mean it was a circle, not an ellipse, because a circle is actually a special type of ellipse, where the eccentricity is 1, if you remember our eccentricity. Okay? We know this is a horizontal ellipse because our x squared term has a smaller coefficient. So as we do our work to get it into standard form, when we divide, the number with a smaller coefficient will actually have a larger denominator, which is what determines whether it's horizontal or vertical. So if we get this in standard form, grouping our x terms together in one set of parentheses, group our y terms together in the next set of parentheses, that 100 gets kicked outside. If we factor out the coefficient from each of the squared terms, we get 4 times the quantity x squared minus 10x plus 9 times the quantity y squared plus 4y plus 100 is equal to 0. And now if we complete the square, half of negative 10 is negative 5. Negative 5 squared is 25. But we didn't just add 25, we've added 4 times 25, we've added 100. So to balance that out, we subtract 100 outside the parentheses. For our y terms, half of 4 is 2. 2 squared is 4, so we add that inside the y parentheses. But we didn't just add 4, we added 9 times 4, we've added 36. So to balance that out, we're going to subtract 36 outside of the parentheses. If we simplify this, half of negative 10 is negative 5, so we end up with x minus 5 squared times 4, plus 9 times half of our b value of 4 here is 2, so y plus 2 squared. 100 minus 100 minus 36 gives us a minus 36 is equal to 0. You can add 36 to both sides now to get this is equal to positive 36, and then to get one side to equal 1, if you divide everything by 36, 4 is going to go into 36 9 times, 9 is going to go into 36 4 times, and 36 divided by 36 is 1. So our equation in standard form, the quantity x minus 5 squared over 9 plus the quantity y plus 2 squared over 4 is equal to 1. So our center is the 0.5 comma negative 2. Pardon me. Since a squared is 9, a would equal 3. Since this is horizontal, our vertices will be to the left and right of our center. So 2 comma negative 2 and 8 comma negative 2. Since b squared is 4, b will equal 2. So our co-vertices are 2 spaces above and below our center. So that takes us to 5 comma 0 and 5 comma negative 4. To find c, the equation for that relates a, b, and c in an ellipse was b squared plus c squared is equal to a squared. We know b squared is 4 and a squared is 9. So if we substitute those in, subtract 4 from both sides, c squared is equal to 5. Which means c is the square root of 5. Our foci are going to be square root 5 spaces to the left and right of our center. So 5 plus and minus the square root of 5, comma negative 2. To make our graph, you start with your center at 5, negative 2. Plot your vertices, so 2, negative 2, and 8, negative 2. Your co-vertices at 5, 0, and 5, negative 4. You can connect them to make your ellipse. That is all of our examples for today. Please reach out if you need any assistance. Good luck with your assignment.